Today again we will talk about anthocyanin pigment. Why? Because it is so important and it is so widely naturally occurring that it needs another lecture to discuss. And one very common plant that we see around us, which is a very big source of anthocyanin dye, and that is rose flowers. You must have seen that there are so many varieties of roses, but the native red colored rose has so much of anthocyanin pigment that it can be a source of huge source of this natural dye. Another thing, because it is used for offering to the god and goddesses, this flower is abundantly also available from the temple waste. So, it can be a real good source of natural dye, and therefore, we will dedicate one more lecture to this anthocyanin pigment and its use, and today's focus will be on the rose pigment that is derived from the rose flower. As you all know that it is a natural pigment and more than 550 different types of anthocyanins are present in fruits and flowers of plants that grow in India. It is the most important pigment of plant after chlorophyll. So, you see, chlorophyll is the green pigment which we all know, and the entire photosynthesis and all that happens because of the chlorophyll pigment, and next to that is the anthocyanin. So, it is that widely and abundantly available. When we talk about anthocyanin dye, we are talking about anthocyanidine plus sugar. And as what I would go back again to the slide and show you what it means. These anthocyanin dyes have other roles also to play. They attract insects on pollination, it poses antioxidant and anti-inflammatory, antimicrobial and anti-cancer activities, and protection from UV vis radiation, and it has also been used as a pH indicator for the first time in our laboratory. So, you see that it has a lot of features that need attention to describe. Now, so today we are going to look at the newer dyeing approach with rose anthocyanin, and therefore, we must dedicate some time to the way the rose anthocyanin is extracted. We must see how it is used for dyeing and what are the shades and the color depths that can be derived on different fabrics, that is cotton, silk and wool, so that we know that there is a huge applicability and we can prove that. As we all know that dyes and pigments are substances that impart color to a material. This is now time and again we have been talking about this. Dyes are usually soluble in water, while pigments are generally not soluble in water. Most dyes are organic compound, whereas pigments may be inorganic compounds as well. Pigments generally give brighter color and may be dyes, even are also they are brighter than the dyes, but still dyes have more applicability. Pigments are only used for printing and other purposes because of their insolubility because of their insoluble nature. Now, there are several advantages, as I have been talking about the advantages of natural dyes, but let us recap and let us have a re-look at it. They are obtained from renewable sources, and our emphasis has been that we should use plant parts which grow again and again. Instead of taking the roots and destroying the plant once for all, it is better to take either the flower or the leaves or the stem, which can be regenerated. They have health and safety aspects, they are biodegradable, and now they have been proven to be cost effective, and they are eco-friendly because of the biodegradability as well as compatibility with the nature. Now, one thing that there was a myth that it is not cost effective, because that time there were no organized farming, the availability was a big factor and there were very few companies who were making natural dyes. So, therefore, they were selling at a very exorbitant price, but that scenario has completely changed in the last few years, and now we have natural dyes available from several companies who sell it almost at a very nominal price. And when we were trying to look at the dissemination of the natural dye technology lecture, I had also shown you that there is only a marginal change in the dyeing cost, a cost varying from 4 to 9 rupees in the case of a shirt and maybe 50 rupees in the case of a sari. So, that is the kind of little cost enhancement. But look at the other aspect, the value addition that the natural dyed fabric brings in is far more than the cost that is enhanced. Now, we are just recapitulating the whole scenario of dyes and natural dyes. So, let us try to look at this particular slide, where we know that there are two types of dyes, natural dyes and synthetic dyes. We have been talking about both, because I want to give you an overview, and then it is up to you to decide what is good, what is bad, because there are goods with synthetic dyes also, there are bad points with natural dyes also. So, one has to outweigh, and whatever is available, that must be trapped. Now, classification of dyes, we have seen that on the basis of chemical constituents, they can be indigoid dyes, anthocyanin dyes, alpha naphthone dyes, flavone dye, anthocyanin dyes and carotenoid dyes. Now, today's lecture will be mainly emphasizing on the anthocyanin dyes. On the basis of their colorant or color present that is there, the dyes can be segregated into red types of dyes or blue types of dyes or yellow dyes or black dyes or brown dyes. However, on the basis of their how they adhere to the fabric, again another definition can come that they are substantiative dye or adjective dye. And among the adjective dye, it could be direct dye, wet dye, modern dye, acid dye, basic dye and dispersed dye. So, these are the various nomenclatures, but when we are talking about natural dyes, they are, as we saw, that they were mostly modern dyes, and therefore, we have to concentrate only on the modern dyes. So, this is how they can be also sourced from plant source. All the anthocyanin dyes are sourced from plant source, but there are other natural dye sources like animal source, particularly for cochineal and lac dye, and there are mineral sources like some of the salts have transition metal salts have color, they can be used as dyes also. Now, this is the most important slide that we must concentrate now. This particular moiety, you see A, B and C, they are three rings which are now nicely beautifully connected, and you see that I wanted to draw this picture and make it very clear to you, because you see this B rings functionality and A ring functionality is very, very important, and that sugar moiety that is hanging at the position of in the C ring is also very conspicuous. Now, because of this kind of arrangement in the molecule, it is possible that the molecule can join the metal very easily. Also, they can chelate with the metal, and the chelate of the metal can then add on to the fabric, the natural fabrics, that is cotton, silk and wool. So, therefore, we can say that anthocyanins have a very good structural detail, very compatible to what is required for an ideal natural dye, because as when we were talking about anthocyanin dyes, I had told you that the alpha hydroxy groups can bring in the metal chelate very easily, and that is what makes alizarin a good dye. Similarly, because of these R prime, R3 prime R5 prime and R5, R6 and R7. These functionalities can be hydroxy groups or they can be other groups which can be helping in the metal chelation. Now, when we try to understand, because we know that the dye and its structure has a great importance in the fact that the more the conjugation in the dye, the better, or the dark is the color. Dyes contain sequence of conjugated double bonds, that is, you have C double bond C and so on, where X is carbon, oxygen or nitrogen. Dyes contain conjugated system of benzene rings bearing simple saturated groups like nitro groups, azo group, carbonyl groups, and these are called chromophores. We have already learnt all this. This is just like a recapitulation, so that now we can connect 2 and 2 and understand it in a much better manner. And the polar groups like NH2 or OH groups, which act not only help in the chelation of the metal atom, but also are called oxochrome because they enhance the activity of the chromophore. These chromophore and oxochromes are responsible for the color of the dye. Now, when we come to, once the dye part is understood, dye is actually whether natural or synthetic, must have conjugated system. This is one of the most important criteria to be categorized as dye. Plus, it must have a chromophoric group and an oxochrome group. Only then it actually becomes an ideal model for being called as a dye. Now, once we have understood about the dye, we also know that natural dyes need mordanting because they are modern dyes. So, mordant binds the natural dyes to the fabric by chemical reaction between the dye and the fiber. So, as I told you that here is a dye, here is a fiber, and the mordant act as a bridging head. So, be it any type of fiber, cotton fabric, cotton, silk or wool, when it is put in the dye bath along with mordants such as alum, copper, copper sulphate, potassium dichromate, stannous chloride, these are the 4 mordants that we tried out. Dyeing can be carried out. It can be also pre-mordanting, meta-mordanting or post-mordanting. So, we know that there are 3 modes of mordant. Mordant can be added in the beginning after the scouring of the fabric, and in the case of cotton we use tannic acid treatment, and then after scouring there is a tannic acid pre-treatment and then mordanting. So, if the mordanting is done beforehand, it is called pre-mordanting. If the mordant and the dye are put in the same dye bath and both are done simultaneously, it is called simultaneous mordanting or meta-mordanting. And the third option is that first after the scouring and after the dyeing, it is then finally mordanted with these mordants. So, the mordants that are used are alum, copper sulphate, potassium dichromate and stannous chloride. Now, time and again I have mentioned that the use of copper and chromium should be minimal, and if possible, if one can avoid, it is even better. But many a times what happens is that we need to have shade variation, and from the same dye extract it is possible to get different shades by altering these mordants. So, as what I told you that there are different types of mordant, and here we will only discuss the metal mordant and the tannic acid which is used as a pre-treatment. Methods of mordanting, we already know that pre-mordanting, meta-mordanting and post-mordanting I have just explained to you. So, it is now it is more like recapitulating what we had done in the last class with the anthocyanin dyes, and also to make you understand that not only hibiscus, even rose which is so abundantly available can be a very rich source of anthocyanin dye. and not many people actually have been into the use of this. Literature review shows that there are some 95 references, and not many people have worked on the chemistry of rose pigment and looked at it from the point of view of a source of textile dye. However, there have been some sporadic information here and there, but nobody has actually worked on anthocyanin dyes. People have worked on the various chemistry, that means what are the chemical components present in the anthocyanin dyes derived from rose, but they have not seriously looked into a possibility of using this anthocyanin dye as a source of textile dye. So, Lawrence et al. Have found out that the principal coloring matter are anthocyanin, anthocyanthins, and even some carotenoids are present. Similarly, the analysis done by Yoshimui, a Japanese group, they propose that stabilization of natural anthocyanin can be done by intercalation with montmorillonate. So, you see, they were only working at an aspect as to how to trap this dye and how to, because as you would know that because of the positive charge on the oxygen, it is a dye which is very pH sensitive, and this we had discussed in great detail in the last lecture, that because of its pH sensitivity, anthocyanin dyes were not considered so far for textile dyeing. So, now if one has to take a look at how the material can be used for dyeing purpose, the flowers of rose, which the botanical name is Rosa rosa, is actually taken and it is extracted, and the instruments that were used for the measurements were UV vis spectrophotometer and color scan machine. And the fabric, there were 3 types of fabric which were used, that was cotton, silk and wool. The chemicals that were used were mordants, that is the metal mordants, alum, copper sulphate, potassium dichromate and stannous chloride, and citric acid and methanol. And cotton was treated with tannic acid only, but silk and wool were only treated with the mordants, that is the alum, copper sulphate, potassium dichromate and stannous chloride. So, this is how the whole overview of the procedure, what all was used and how they were used. The methodology is that washing and preparation of the fabric is carried out first, then the extract of the methanolic extract of anthocyanin is done. But while doing the methanolic extract, a little bit of citric acid addition can always enhance the extract quality, and the more and more dye can come into it. Then the dyeing of the citric, this fabric with the anthocyanin extract can be done. But before we do the dyeing of cotton fabric, tannic acid treatment is carried out, then it is dried, then mordanting is carried out. Now, in order to see whether the dye is really anthocyanin or not, UV visible spectrophotometer testing is carried out of the extract. The extraction of anthocyanin dye actually is the most crucial part, because the more we can extract the color from the biotic material, the fade, the more concentrated will be the solution, and that can be figured out. If the biotic material is getting faded, that means all the colorant has come into the methanolic, acidified methanolic solution. So, that is a test to evaluate whether all the dye has come or not. It is not required to heat it for too long time, only a slight heating can actually bring out the color. And once that is done, once the dyeing is carried out, the LAB values are evaluated, and before doing that before the dyeing or rather before the dye fixing and after the dye fixing, the LAB values show how much of the dye has actually impregnated into the fabric. And therefore, there is a need for dye fixing, and citric acid is one very good example which was tried out. It is a mild acid and it does the retention of the color on the fabric, the dye adhesion enhances. Now, if we try to look at the the UV visible spectra of the anthocyanin derived from rose, you can see that there is a very distinct peak, and anthocyanins are known to have a peak between one band in between 475 to 560, as what we saw in the case of hibiscus also, which falls in the visible region, and the second band, which is at 275 to 280, is in the UV region. And rightly so, we found a very appropriate band at 526 nanometer, which shows an absorbance of 0.94, and the yield that was calculated was about 4%. So, you see that this dye source already has, just from the flower petals, 4% of dye can be extracted readily from the rose dye. Now, when the LAB values for cotton fabric dyed by the rose anthocyanin was characterized, before fixing with citric acid, the values showed that the K by S values were between 62 or rather 50 to 132, and the highest being for stannous chloride. This is the same observation that we had in case of hibiscus anthocyanin also. So, you see that stannous chloride seems to be the ideal mordant for this rose anthocyanin, and it is also. So, we can conclude that for anthocyanin dye, stannous chloride mordant seems to be having good functionality, and it does not fall into the dangerous category like copper and chromium. So, it can be safely used, but every time we are using mordant, it should be kept in mind that the minimum amount of mordant should be used, otherwise there could be problems arising in the effluent treatment or effluent management. Now, when the same cotton dyed fabric is treated with citric acid, the dye fix shows that lot of dye has run off. You see, that means that dye fixing. Now, what is the situation of the K by S value? We should not get perturbed by the fact that, oh, so much of dye has run off. Even then it has very rich color, and we will see the fabric very soon and we will then understand. And here also the K by S value shows that for stannous chloride the value is 130. So, if we go back from 132, it has only reduced to 130. So, treatment with citric acid has not reduced the color strength in the case of stannous chloride, whereas in the case of other mordants and in the case of control fabric, it has shown considerable change. So, this also goes to indicate that for rose anthocyanin, the ideal mordant is stannous chloride. Now, you see that as compared to the hibiscus fabric which you had seen last time, the controlled fabric, look at the control fabric which has been just treated with the pre-treatment tannic acid, and the alum piece and the copper sulphate piece, the potassium dichromate piece and the stannous chloride piece. So, you see stannous chloride shows very deep color. Similarly, if we take a look at the silk fabric before the treatment of the citric acid, before fixing with citric acid, you will find that the K by S values vary from 48 to 137, and here also the compatibility is best for stannous chloride. Similarly, if we go to the fabric treated after fixing with citric acid, the values have decreased from 137, it has decreased to 111, but still it is showing good values for K by S values, and therefore, stannous chloride is also rightly suited for the compatibility of rose anthocyanin. And the fabrics look little faded in this case, but definitely stannous chloride is much darker for silk as well. Now, when we try to look at the wool samples and we try to see what is the situation of the anthocyanin dyed fabric before citric acid treatment, they range, the K by S value ranges from 63 to 222, which shows very good dye uptake. You see, K by S value shows dye uptake, but some of it is only adhering to the surface. So, the moment the citric acid fixing is done, you will see that the color runs off. Here also the compatibility goes to show that stannous chloride is showing the best result in the case in the terms of K by S value, which is the color strength. Now, when it is fixed with citric acid, it was found that it has reduced from 222 to 119, which is almost like going half the way. So, one can see, but even then the stannous chloride value stands out. But here in this case, in the case of wool, even potassium dichromate shows reasonably good values for K by S. So, both now we can say for wool, potassium dichromate and stannous chloride both can be used readily. So, you see it is obvious from these even dyed samples, if you see this dyed samples, one can evaluate these things what I have told you just now. Now, so if we have to take an overview of the K by S value only, it in each case, then let us go in the increasing order. In the case of cotton, the order of K by S value after fixing was found, because see before fixing we cannot say that this is the best method, because after all the fabric needs to be treated completely. The finishing process must be complete. So, finishing of the fabric ends only in the step of dye fixing. So, therefore, these values are of more important, but that was more to see how much the dye is taken up and how much is run off in the water. So, if we try to look at the cotton values, control is poorest, then alum, then copper sulphate, and then potassium dichromate, and then stannous chloride. And in the same is the sequence in the case of silk, control, copper sulphate, alum. So, you see potassium dichromate and stannous are the two mordants which are quite good for cotton and silk. And similarly, we will see that in the case of wool also after fixing, alum was the worst. It was even worse than the, so it cannot be recommended at all for wool dyeing. But copper sulphate, potassium dichromate and stannous. So, finally, what do we come to a conclusion if we by looking at the K by S value, that potassium dichromate or even better is stannous chloride, that should be used as a mordant for this dyeing of cotton, wool and silk by rose anthocyanin. So, if we now have to conclude, anthocyanin pigments was extracted from the petals of Rosa rosa, which is rose, and by using it pure natural fabric for dyeing, better results were obtained with few particular mordants, but the best result was obtained with stannous chloride mordant with good washing fastness. Due to their non-toxic properties, low pollution and less side effects, there is an increasing awareness among people towards natural dyes. Most of the flowers contain anthocyanin dyes, and it can very well be used as a dye material, giving primarily different shades of reds and pinks, The wash fastness of metal complex dye is due to the ability of the dye molecules to associate with large aggregates in the fiber and because of the intermolecular hydrogen bonding. So, you see the way one can have an overview of why now it is time to accept anthocyanin dyes as textile dyes, because they fit into the category of the features that a textile dye must have. That is, the dye should be soluble in water, the dye should have good functional or oxochrome groups, so that the metal mordant can attach, and subsequently the metal mordanted dye will be able to attach on the fabric. And if a dye follows all these parameters, or if it has these characteristics, if it is abundantly and cheaply available, if it is having the right kind of functionality. Now, you see that there are many chemicals or compounds of this, and many possibilities are there where the R3 prime, R5 prime, R5, R6, R7 in the A ring, and the cleavage of this particular. Okay, so the A group, the A ring, the C ring and the B ring, and the different functionalities and the cleavage of this giving rise to anthocyanidine are responsible for good functionality and good linking of the metal ring and metal and the rings and the structure, and therefore, these dyes are very appropriate for textile because they have the right kind of functional group. If we have to now look at the overview that anthocyanins, why they were not tapped, why is it that this dye had so much, I mean it was so abundantly available from time immemorable, but why is it that it did not enter into the textile market? Because of the simple reason that extraction process and the dyeing process were not standardized. We tried to standardize the extraction process, and we also tried to look at, that means we tried to standardize the extraction, and the extraction of anthocyanin dyes with the help of methanol plus citric acid was evaluated by us for the first time, because we thought that if more and more dye has to be extracted, it is necessary to find a method for extraction, because what was happening, by using just water, the dye was not coming completely into the aqueous solution, and by using methanol, methanol cannot be used for an industrial process. So, we tried to take a 50-50 solution of water and methanol and added a pinch of citric acid just to alter the pH. Now, this alteration of the pH actually helped in extraction of the complete anthocyanin that was present in rose. So, that is where there was an edge, that is where the technology that we developed had an edge over the existing aqueous extraction process, and that really helped, because we were able now, after the extract was obtained, either we use it immediately after 50% concentration, or we put it on the rotary evaporator. See, there was a step, I will go back to the slide so that you can recall that during the process of extraction or methods and material that we were discussing, this extraction of rose, there was a use of rotary evaporator. Now, this rotary evaporator actually can remove the methanol completely and water as well at reduced pressure. So, it does not hamper the chemical moiety of the anthocyanin dye, and because the dye is intact and there is the pH is slightly acidic, it can be left in the room or on the shelf for months, and it can be just used at the time of use. So, the problem that we were facing about natural dye, that the extract should be immediately used, otherwise it goes bad, or if the the difficulties that natural dyes normally had, those we were trying to overcome. And in the case of rose dye, particularly because it was so abundantly available, we have done a lot of standardization, not only in the terms of dyeing, but also the major breakthrough was in the process of extraction and preservation of that dye. Can we keep that dye? Does it get deteriorated? No, it does not get deteriorated even with daylight, and does not get fungal growth, because there is a slight excess of citric acid which keeps the pH at a level where fungus do not grow. So, that way we were able to preserve these dye paste and use it at a later date. So, that is what made this dye such a good dye, and it is such a rich source. So, let us now conclude this lecture that anthocyanins can be a good textile dye because of their cost effectivity, high availability and good compatibility with the fabric, all the three natural fabrics: cotton, silk and wool.